Okay, I'm going to give you an overview of factoring polynomials. Now, I have a menu here, and everybody should have this menu in your notes. But if you don't, I want you to pause this video, and I want you to make sure you have this written down because this is really, really important. So pause your video right now and write all this stuff down and have it there with you when you're factoring your polynomials. This is the exact same menu we have in class. Do that right now and then start up the video again. Okay, number one, you always look for a GCF no matter what. And if you do pull out a GCF, you're going to include it in your final answer. So here's a good example of a GCF. If I have 2x to the third plus 18x squared plus 28x, and I'm looking for a GCF, I know that 2 is a factor of 2 and 18 and 28. So I know I can pull a 2 out of all three of these. Is there anything else that these three terms have in common? Well, they all have at least one x, so I can also pull out an x. So now what we're going to do is distributive property in reverse. So 2x times what is going to give me 2x to the third? Well, all I need to go from here to here is 2 more x's. So if I multiply these together, that's 2x to the third. Okay, 2x times what is 18x squared? Well, I know that 2 times 9 is 18. I know that x times another x would give you x squared. And I know that a positive times a positive equals a positive. So this times this equals 18x squared. Okay, and 2x times what is 28x? Well, I know that 2 times 14 is 28. And 2x times 14 is 28x. A positive times a positive is a positive. I think we're done, but let's double check. 2x times x squared, I have 1, 2, 3, x to the third, and a 2. Boom, done. 2x times 9x, 2 times 9 is 18. X times x is x squared. Boom. 2 times 14 is 28. 28 and 1x, 28x. Boom. So I successfully pulled out the GCF. Now I'm going to try and factor this some more, but I always have to remember that that GCF is going to be in my final answer when I'm done. And if I can factor this some more, then I'll have my GCF and 2 more factors. If I can't answer this or factor this anymore, then my answer will be the GCF times this trinomial. That's pulling out a GCF. Again, I didn't finish this. I'm just showing you how you pull out the greatest common factor. Number 2, we're going to look for special cases. And there are 2 special cases. PST stands for perfect square trinomial. And the way you factor a perfect square trinomial is a binomial squared. Now here's an example of a perfect square trinomial. X squared plus 6x plus 9. Now, if I was asked to factor this, I would start at the top and look for a GCF. None of these share any factors in common, so there's no GCF. Now, I'm going to look for special cases. Is this a perfect square trinomial? Well, it is a trinomial. I do know that, and a perfect square trinomial has to be a perfect square. And the first and last terms, it has to be a trinomial, and the first and last terms have to be perfect squares. Well, is this a square term, and is this a square term? Well, the square root of x squared is x, and the square root of 9 is 3. So these both have perfect squares, so this is a perfect square. Well, I guess it's a perfect square trinomial, but we have to do one more thing. We're going to multiply these together, and we're going to get 3x. And then we're going to double 3x. And if I double 3x, I get 6x. And that's my middle term, isn't it? So this is a perfect square trinomial. So here's how you factor it. When you factor a perfect square trinomial, you're going to get a binomial squared. What that means is you're going to have a binomial and the whole thing is going to be squared. But what goes in your binomial? Take the square root of the first term, which is x. Take the square root of the third term, which is 3. And take the sign of the middle term, which is positive. And you've just factored that PST. Now, what if you don't know it's a PST and you try to do X-man if the leading coefficient is 1? Well, if I do X-man, my A times my C is going to be 1 times 9, which is 9, and my B is going to be 6. And the two numbers that I multiply to get 9 and add to get 6 are 3 and 3. So I would write this as x plus 3 times x plus 3. But that is x plus 3 times itself 2 times. So I want you to write your final factorization for something like this as x plus 3 quantity squared. That's the right way to do it. Even though this is technically correct, I want it written like this. And if you have a binomial squared as your factorization, then this is a perfect square trinomial. Now, what if I had this exact same thing, only the middle term was not 6x? What if I had x squared plus 10x plus 9? Would this be a perfect square trinomial? Nope. This is a square number and this is a square number, but the square root of x squared is x and the square root of 9 is 3. Multiply those together and you get 3x, and if you double 3x you get 6x. Well, my middle term isn't 6x, it's 10x, so it's not a PST, but I can probably or maybe still factor it. So it has a leading coefficient of 1. It doesn't have a GCF, so I'm going to factor it. Oh, and it's not the difference of two squares, so I'm going to factor it using X-man. A times C is 9 and B is 10. Well, I think 9 times 1 is 9 and 9 plus 1 is 10. So the way I would factor that would be x plus 9 times x plus 1. Dun 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 dun. Not a PST, but I could still factor it. Maybe I can, maybe I can't, but you got to try. Okay, my next special case I'm going to look at is called dots, and dots stands for difference of two squares. Now let's think about that. I know difference means I'm going to subtract something. Two squares means I have two terms and they are both square numbers. For instance, x squared is a square term. I can take its square root, and 16 is a square term because it has a square root. So guess what? This is the difference of 1, 2 squares. And of course this is always going to be a binomial because it only has two terms, not 3. So this is dots. So if I recognize this as dots, I instantly know the way I factor dots is sum and difference. And sum and difference looks like this. Sum means add, difference means subtract. And what's going to go in here? Well, the square root of x squared is x. That's going to go here and here. And the square root of 16 is 4, and that's going to go here and here. Now, you want to be sure, put these two binomials in a Punnett square, multiply it back out, and I'm pretty sure you're going to get this. Now, what if I have this? What if I have 4x squared minus 100? When I look at that, I notice that that's the difference of two squares. This is a square, this is a square, this is the difference of two squares. But what's step number 1? No matter what, look for a GCF. Well, does this have a GCF? You bet it does. I can pull a 4 out of here and here. There's my GCF, but now look at this. This is still the difference of two squares. So I factor that using sum and difference. The square root of x squared is x. The square root of 25 is 5. Don't forget that that GCF you pulled out is still part of the complete factorization and part of a correct answer. If I multiply this times this, I'm going to get that. And if I multiply that times 4, I'm going to get my original expression.